Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like percentages, profit and loss, mixtures allegations, coordinate geometry, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, remainders. In this video, we are going to see some basic concept of remainders along with the concept of negative remainders and how we can find the remainder when higher powers of numbers are divided by a divisor. And in the next part, we'll be seeing some theorems like binomial theorem, Fermat's-Rittel theorem, etc., which will help us to find the remainders easily. So let us start with today's video. Let us first start by seeing what is a remainder. Say I have this number 17 and I want to divide this number by say 7. We know 7 times of 2 will give us 14 and there would be an extra 3 here. So this 3 is called as the remainder and this 7 is called as the divisor and this 2 is called as the quotient. So whatever the extra part that is not divisible further by the divisor is called as the remainder. And any number can be written as divisor times of quotient plus the remainder. In this case, the number 17 would be equal to divisor, that is 7 times of the quotient, which is 2 plus the remainder. Since the extra part that is not divisible by the divisor is called as the remainder, so we can say that the remainder will always be lesser than the divisor. Now, there are some points which we need to keep in mind in case of a remainder whenever a number is divided by a divisor. The first is whenever a division is split into a sum of 2 divisions, in that case, the original remainder will be equal to the sum of the remainders of the 2 individual divisions. Now, what does this mean? Okay, so let us take the same example, 17 by 7. I know when this 17 is divided by the number 7, then the remainder is 3. Now, instead of writing the remainder as 3 directly, what we can do is we can split this 17 by 7 and can write it as 9 by 7 plus 8 by 7. And we know that when we divide 9 by 7, in that case, we'll be getting the remainder as 2. And when we divide 8 by 7, in that case, we'll be getting the remainder as 1. So the sum of the remainders of these 2 individual divisions, that is 2 plus 1, is equal to the original remainder, that is 3. So we can split a division into a sum of 2 divisions to get the original remainder. The same is also applicable when the division is split into difference of 2 divisions. For example, 17 by 7 gives us a remainder of 3, and this 17 by 7 can be split into difference of 2 divisions. That is, I can write it as 25 by 7 minus 8 by 7. So 25 by 7 will give us a remainder of 4 and 8 by 7 will give us a remainder of 1. So the total remainder would be 4 minus 1, that is 3. So the division can also be split into difference of 2 divisions to get the original remainder. Now, the same is also true when a division is split into a product of 2 divisions, keeping the divisor same. For example, say I know when we divide 48 by 7, we get the remainder as 6. Now, 48 by 7 can be split as a product of 2 divisions having the same divisor 7, as 8 by 7 times of 6 by 7, because 8 times of 6 gives us 48. Now 8 by 7 will give us a remainder of 1 and 6 by 7 will give us a remainder of 6. So the original remainder would be the multiple of this 1 and 6, which would be 6. And we know that when we divide 48 by 7, the remainder is 6. So the same is also true when a division is split into a product of two divisions with the same divisor. This division split as a product would be very much helpful whenever we would be finding the remainder of the higher parts of a number divided by a divisor, for which we would be seeing some questions as well. Now, suppose if I have this number 26 and I want to divide it by the divisor 4. I know when we divide 26 by 4, in that case, the remainder would be 2. But before dividing 26 by 4, what we can do is we can reduce it into its lowest form as 13 by 2, because 2 is the common factor between 26 and 4. So we can cancel this and we can reduce it to 13 by 2. But now, if we divide 13 by 2, in that case, the remainder would be 1. But we know when 26 is divided by 4, the remainder is 2. So whatever the remainder we get after reducing the number and the divisor to its lowest form, we need to multiply this remainder with the common factor by which we are reducing the number and the divisor. In this case, the common factor by which we have divided the number and the divisor is 2. So we need to multiply here by 2. So this would be 1 times of 2, which would be 2. And that's the remainder when 26 is divided by 4. So in such cases, when we are cancelling the common factor from the number and the divisor, in that case, whatever the remainder we get, we need to multiply it by the common factor to get the original remainder. Now, let us see the concept of negative remainder. Generally, whenever the remainder that we have is comparatively of higher magnitude, in that case, we can use this negative remainder concept. To understand this clearly, let us take an example here. Suppose if I'm dividing the number 31 by 8, I know the remainder would be 7. This 7 is called as the positive remainder. Now, if we subtract the divisor from this positive remainder, so this would be -1. So this -1 is called as the negative remainder. To get back to the positive remainder from the negative remainder, what we can do is we can add the divisor to this negative remainder to get the positive remainder. So either we use the positive remainder or the negative remainder, we'll be getting the same answer. But in case the remainder is of comparatively higher magnitude, we'll be using the negative remainder concept, because in that case, we'll be dealing with numbers of lesser magnitude. Let us see one example to see the benefit of using the negative remainder. Suppose if I have this number 62 times of 62 times of 62, and I want to divide this number by 7, and I want to find what would be the remainder. Well, what we can do is we can take the cube of 62 and then we can divide that number by 7 to get the remainder. That is one thing that we can do. Or what we can do is the remainder of 62 times of 62 times of 62 upon 7 would be the same as the remainder of 62 by 7 times of remainder of 62 by 7 times of remainder of 62 by 7. So from here, the remainder would be 6 times of 6 times of 6, and this would be divided by 7 because the numerator would be greater than 7. So this would be 216 by 7, and when you divide 216 by 7, in that case, the remainder would be 6. So this is another way by which we can find the remainder. Now, let us try to find the remainder using the negative remainder concept. I know that the remainder of this number would be the remainder of 62 by 7 times of remainder of 62 by 7 times of remainder of 62 by 7. So using negative remainder concept, what we can say here is the remainder of 62 by 7 would be 6 as the positive remainder, but it would be -1 as the negative remainder. Similarly, the remainder of this 62 by 7 would be -1 in terms of negative remainder, and the remainder of this 62 by 7 will again be -1. And in the denominator, there would be 7. So this would be minus 1 times of minus 1 times of minus 1. So that would be minus 1 by 7. So the negative remainder when this number is divided by 7 is minus 1. So the positive remainder would be simply minus 1 plus the divisor, which would be 7. So that would be 6. So we can see simply by using the negative remainder concept, we can find the remainder easily. Well, here this 62 is 3 times. Just imagine if this 62 is say 10 times or 20 times. In that case, if we use the positive remainder concept, in that case, we need to write this 6 10 times or 20 times. So it would be a little bit difficult to find the remainder in that case. But if we use the negative remainder concept, in that case, in the numerator, we'll be getting minus 1 times of minus 1 times of minus 1 and so on. So in the numerator, we'll be getting minus 1 or plus 1, depending whether 62 is odd number of times or even number of times. So in that case, the remainder would be plus 1 or plus 6. So we can see that simply by using the negative remainder concept, we can find the remainders easily. So that's why when the remainder's magnitude is comparatively higher, it would be better to use the negative remainder concept to get the remainder. Now, let us find some remainders when these numbers are divided by 7. So the first one given here is 120 plus 121 plus 122 divided by 7. Well, one thing that we can do here is we can add these three numbers and then we can divide it by 7 to find the remainder. Or what we can do is the remainder of this sum would be same as the remainder of 120 by 7 plus the remainder of 121 by 7 plus the remainder of 122 by 7. Now 120 by 7 will give us a remainder of 1, 121 by 7 will give us a remainder of 2, and 122 by 7 will give us a remainder of 3. So the total remainder when 120 plus 121 plus 122 would be divided by 7 would be simply 1 plus 2 plus 3, that is 6. Now this 6 is lesser than 7, so we cannot divide further, so this would be the final remainder. In a similar way, when 121 square would be divided by 7, the remainder would be same as the remainder of 121 by 7 times of the remainder of 121 by 7. Now 121 by 7 will give us a remainder of 2. So 121 square divided by 7 will give us the remainder of 2 times of 2, that is 4. Now let us find the remainder when 121 raised to power 36 is divided by 7. Well, again, we can apply the same method that we have applied in the second one. That is, the remainder of 121 raised to power 36 divided by 7 would be the remainder of 121 by 7 times of remainder of 121 by 7 times of remainder of 121 by 7 till 36 times. So 121 by 7 will give us a remainder of 2. So this would be same as 2 times of 2 times of 2 till 36 times divided by 7. So the remainder of 121 raised to power 36 divided by 7 would be same as the remainder of 2 raised to power 36 divided by 7. Now 2 raised to power 36 can be written as 2 raised to power 3 raised to power 12 upon 7, which would be 8 raised to power 12 upon 7. Well, I am writing 2 raised to power 3 as 8 because when we divide 8 by 7, the remainder would be 1. So when 8 raised to power 12 is divided by 7, in that case, the remainder would be 1 times of 1 times of 1 till 12 times, because when we divide 8 by 7, the remainder is 1. So this would be 1 times of 1 times of 1 till 12 times, that would be 1 divided by 7, or the remainder would be 1. Now let us see the fourth one. So here we have 121 raised to power 121, and we need to find the remainder when this is divided by 7. Well, again, the remainder of 121 raised to power 121 divided by 7 would be same as the remainder of 121 by 7 times of remainder of 121 by 7 times of remainder of 121 by 7 till 121 times. So 121 by 7 will give us a remainder of 2. So this would be same as 2 raised to power 121 by 7, which can be written as 2 times of 2 raised to power 3 to the power 40 upon 7, which would be 2 into 8 raised to power 40 upon 7. Now we know that when this 2 would be divided by 7, the remainder would be 2. And when this 8 raised to power 40 would be divided by 7, the remainder would be 1 raised to power 40 upon 7. That would be 1. And this would be divided by 7. So the remainder would be 2 in this case. Now let us find the remainders of this 2 division. The first is 2 raised to power 58 divided by 24. We know 24 is 2 raised to power 3, that is 8 times of 3. So in the numerator, we have 2 raised to power 58, and in the denominator, we have 2 cube into 3. So we can remove 8 from the numerator and denominator, and then we can find the remainder. And whatever the remainder we have, finally, we can multiply 8 to get the actual remainder. So from here, we can write it as 2 raised to power 55 divided by 3 after cancelling the common factor 8 from the numerator and denominator. Now we have 2 raised to power 55 upon 3. So we know that when we divide 2 by 3, the positive remainder is 2, but the negative remainder is -1. So this would be the same as the remainder of -1 raised to power 55 upon 3. Now, -1 raised to power 55 would be -1 upon 3. So here the negative remainder is -1. So the positive remainder would be simply -1 plus 3, that is 2. But since we have cancelled the common factor 8 from the numerator and denominator to get this remainder, so the actual remainder would be simply 2 times of 8, that would be 16. Now, let us see the second one. So here we need to find the remainder when 2087 raised to power 2087 is divided by 9. Well, initially this seems to be a very difficult problem, but if you observe carefully, the remainder when 2087 is divided by 9 is 8, that is the positive remainder, or we can say that -1 would be the negative remainder. So the remainder of this can simply be written as -1 raised to power 2087 divided by 9, which would be -1 upon 9, because -1 raised to power some odd number would be -1. So -1 is a negative remainder. So the positive remainder or the actual remainder would be -1 plus 9, that would be 8. So you can see how simply by using the negative remainder concepts, we can find the remainders easily. So that's it for today's video, in which we have seen some basic concept of remainders along with the concept of negative remainders and how we can find the remainders when higher powers of numbers are divided by a divisor. And in the next video, we'll be seeing some theorems like binomial theorem, Fermat's little theorem, etc., which will help us to find the remainders easily. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.